13.4 inverse trig functions. This is going to be continued from where we left off last time, and the objective here is we just have a couple more left for this unit with inverse trig functions. Is it helps us to solve an equation, solve the equation for theta. So given the ratio of two sides, you have to find then the angle. And we're only going to do this in degrees for now. So your calculator can be in the default degree mode when you do this. So we did example 1 last time already, and that's in the previous video. So now we're on example 2, which is to find the equation is tan theta equals 2.1. And we want to make sure that our answer for this is between 180 and 270 degrees, which we'll draw a picture of in a second. So we want to solve that. So do you remember what to do to find theta? Theta equals then, so this is the ratio of two sides, 2.1. I want to know the angle. I want to go the reverse way, so I take the inverse tangent, which is that symbol, that little -1 of 2.1. So on your calculator, put 2.1 in and look for the button above tangent, and you should get that theta equals, did you try it? Yeah, 64.5 degrees. Now the problem, now we're gonna draw this over here. The problem with that is 64.5 degrees is about right here, okay? Right? Rotate, we always rotate from 0 degrees, 64.5, but we need our answer to be between 180 and 270. So we want, instead of using this, we want the equivalent angle in this quadrant. So instead of saying 64.5, we're going to draw the same angle that's the same distance from the x-axis. So we know that this is 64.5 degrees, but we want to know this angle from here to here, because you know with the symmetries in this unit circle, there are two quadrants where the tangent is positive, and that's in quadrant 1 and 3. So there's actually two places that would give you the same answer, that where the tangent is 2.1. So use your geometry skills and just looking at this picture to tell me what is the final answer. Knowing that this is 64.5 degrees and all the symmetry, how would I find this answer? Very good. I would just take 180 degrees and I would add, because we all know that's 180, and I would just go a little bit further, 64.5. So my answer is 244.5 degrees, yeah. So that's what you would say for your answer. So it's just that little extra step that's the only tricky part. Let's try the sine of theta. See if I can make it a little bit harder. -0.23. Okay, solve the trig equation. So I would say that theta equals, the answer is the inverse sine of -0.23. So make sure your calculator is in degree mode. If it says rad on there, that means radian mode. That's not going to give you your answer in degrees. And what do you get? And sorry, the original problem says that theta has to be between 270 and 360. That's key information. So when you use your calculator, what do you get? You got -13.3 degrees. Okay, great. And the reason you get that is because, remember, inverse tangent is defined in quadrant 1 and 4. We said that last time. So what your calculator is telling you is this answer. And so it's not technically, there's nothing wrong with that, but what we want, the question we're being asked is to find theta between 270, between rotating 270 and rotating 360. So we need it to be the other version of that angle. We need this angle from here to here that's coterminal. that gets us to the same place. So what's another way of saying, using the geometry of this circle, what's the other way of saying that same angle? Yep, you would do 360 minus 13.3. You just have to take that last little step using the picture that you draw. And so the answer is 346.7 degrees. Let's see, let's do one between, we'll do one more of these, and then I'll show you how you can use this with triangles to find angles. So example 4. You try this one. The cosine of an angle is negative 0.39, and I want to know what that angle is, but theta has to be between 180 degrees and 270 degrees. So you try that. Okay, so did we get 113 degrees so far? Okay. Now, we need our answer to be in this quadrant, though. So you draw the equivalent angle. So the cosine is also negative in this quadrant as well, right? So that's the equivalent angle. It's the same distance from the x-axis. Why is the cosine negative in these two quadrants? What's the easiest way to explain why the cosine is negative in these two quadrants? Negative 0.39, right? Cosine is which coordinate, the x or the y? Cosine is the x coordinate. And do you see how in the coordinate system, when you go to the left, that's these two quadrants, right? So the x coordinate is negative in these two quadrants, so it's one of these. So I just want you to tell me what the same equivalent angle is using geometry. That angle, what's the equivalent? So how would we get that? Knowing that this is 113, how would we get this one? Yeah? Yeah. Yeah, John's got a good eye for geometry here. Do you guys see how he came up with that? Okay, so do you see how these two parts are the same? 113 this way and 113 that way, because the symmetry. Do you see how this distance from here to here is going to be the same as that? Okay. And do you also agree that in a complete, if we go all the way around the circle, it's 360? So what he did is he went all the way around the circle, 360, but then he backed up 113. And that gives us the angle that we want. Yep. So that gives us 247, I hope. Yeah. Okay, good. And we got it. So that's one objective for this unit. And then the last thing is we're going to use this in triangles, and you might have already done this in geometry, and it's so simple, but students forget that they know how to do it. So the objective is to find the angle given the picture. So we'll just do two examples. We're only doing right triangles here. If I tell you these sides 10 and 13 and I say find theta, students just struggle and struggle and struggle to find that angle. But what do you do? Wait, what's that? You want to use, can you use sine? You're going to kind of use SOHCAHTOA, yeah. And which one would we use? Tangent. So watch. You would just say the tangent of the angle is opposite over adjacent, right? Those are the two given sides. Opposite over adjacent. And now you use what we just learned, right? Inverse tangent. Yeah? You're given the ratio of two sides, even though it's before we were doing decimals, but 10 over 13 can be translated into a decimal. So you just say theta equals the inverse tangent of 10/13. It's no different than the problems that we've just been practicing, except we were looking at it in a circle, and now we're looking at it in a triangle. So you get do you get a reasonable answer? Do 10 divided by 13 and take the inverse tangent. And if we get a reasonable answer, we leave it like that. 37.6? 37.6? Okay, I must have, did anyone get anything different? Okay, 37.6 degrees. I must have written mine wrong then. I'm going to take your word for it. That's it. So let's do one more. Let's make it this way, and I'm going to tell you this. I want to find theta here, which is too small to draw it in there. And this hypotenuse is 18, and this side is 3. That's supposed to be a right triangle. Let me make it look a little bit neater. Okay, tell me that angle. So which trig function do we use? It's got to be sine, because you're given the opposite over hypotenuse. Unless you use Pythagorean theorem and find the third side, then you could use any ratio you want, but that's extra work. So let's just do the one that we have, 3 over 18. So the angle is the inverse sine of 3 over 18, so just do that. The inverse sine button is above the sine button. 1/6, And what do we get for the angle? 9.6. One place past the decimal is fine for angle.